Global variable and equations can be used in design to SolidWorks models to create mathematical relationship between dimensions. Global variables allow you to define a named value within a model that dimensions can be set equal or that can be used in equations. Besides just utilizing global variables, SolidWorks equations can make use of existing model dimensions. Incorporate mathematical functions, file properties, and measurement of the model to build in the desired design intent. By taking advantage of global variables and equations, you can leverage the full benefits of working with a parametric model and ensure features update as intended when modifications are made. In this tutorial, I'll demonstrate some techniques for adding global variables and equations and show how they can be used to control the geometry of this part. I have decided to make all the small fillets and rounds on this housing design have the same drills. To ensure that the dimensions from the separate features always remain equal, I'll create a single global variable to control them. Global variables are defined within the equation dialog. I can access the equation dialog from the minus under tools, equations. The equation dialog has buttons at the top that enable four ways to information. Each view shows a different combination and sequence of the equation's global variables and dimensions. To help you perform tasks such as finding a specific equation, viewing all dimensions used in part and changing the order in which equations are solved. The equations view accessed with this icon here shows only global variables and equations that exist in the model and groups them into categories. Equations that are created to control the separation state of features are categorized separately from equations that drive dimension values. Sketch equation view allows you to enter equations that drive dimension value within a sketch. Here you can reference existing sketch dimensions or utilize other mathematical functions to drive a sketch dimension. The dimension view will list all dimensions that exist in the model. Dimension names and values can be modified here. The ordered view option shows global variables and equations in the order they are solved. By default, equations are solved in the order they are created. Using the option automatic solve order at the bottom of the dialog allows SolidWorks to automatically determine the order of equations to avoid potential social issues such as infinite loops. Alternately, this view can be used to reorder equations. This is also the only view where an equation that has been suppressed can be accessed. The search any of these views of specific values, equations, global variables, or dimensions. I can use the filter field to of type of information I am looking for. I'll use the equation view to create the global variable for the fillets in this part. I will left click on the cell to add global variables and name it SM radius. I'll click in the value equation cell and set the value to 3. I'll also add a comment to make sure the purpose of this variable is understood. Clicking OK will close the dialog. The next step is to set all the dimensions for the small fillet features equal to the newly created global variable. I'll double click fillet to so I can access the feature dimension in the global graphics area. Double click the dimension causes the modify box to appear. And typing an equal sign allows to me define an equation to drive this dimension. When creating an equation, a drop down menu becomes available with options to use within the equation. I'll choose global variable from the list and select the SM radius value I created. I'll click OK to accept the dimension and complete the link to the global variable. Note that the dimension is now shown within an equation symbol preceding the value. If I double click the dimension again to modify it, I can see the value is grayed out and cannot be directly changed. There is also a button shown with the global variable icon. This button can be selected to toggle between the dimension value and the global variable name being used. I'll repeat the same procedure to set the other small fillet feature equal to the global variable. Fillet 4, fillet 5, and fillet 6 will be a set to use the same value, and I'll rebuild the model. At this point, I wish to modify the radius for the small fillets in the part. I simply need to change the value for the global variable, and all these separate feature will be updated. To test it out, I'll access the equation dialog again and make a change. Once there are global variable or equation that exist in the model, the equation dialog can be accessed directly from the feature manager tree. An equation folder is now shown here and can be expanded to the view global variables that have been created in the model. The display of this folder is controlled by system options. Right-clicking in the feature manager pawn provider a shortcut to access option to hide and show tree items. The default setting is to have to equation folder set to automatically show, which means it allow only available when equation exists in the model. But if I prefer to always have the folders shown or hidden, the options in the down menu allow me to accomplish this. Now back to the model. To access the equation dialog from the feature manager, I can right click on the equation folder or any variable listed and choose manage equations from the menu. The equations I defined the a part have been added to the equation list in the dialog. Before making a change, I want to point out that I have an option selected automatically rebuild. This will allow the model to rebuild as I make modification within this dialog so I can preview the changes. I will highlight the SM radius value, change it to 5 and hit enter. I can see the equations update as well as the model geometry. I'll preview the value of 1 for the small radii of the part, and I can see the model is behaving. I'll change the value back to 3 and select OK to close the dialog. Besides just setting dimensions equal to each other, global variables can also be useful for mathematical expressions. For instance, this model was designed by creating half of the part, then mirroring it to create the desired symmetry, so the dimensions driving the design of the plate and housing feature represent half widths rather than total width of the finished model. I'll create a global variable to define the overall width of these features and use equations to properly control the value in the mirrored feature of the part. I'll start by accessing the equation dialog once again and click in the cell to add an additional global variable. I'll name the first one overall boss and give it a value of 125. You can quickly navigate through the fields in the dialog box using the tab key on the keyboard as well as clicking with the mouse. I'll add another global variable named overall base and set it equal to 245 and click OK to close the equation dialog. Next, I'll add an equation to control the width of the plate feature. Double click the face of the feature will give us me access to this dimension in the graphic area, and I'll double click in 110 width dimensions to modify it. I'll type an equal sign and start the equation with the global variable I created for the overall base. Since this dimension represents half of the overall width, I'll type /2 to the keyboard. The tooltip next to this cursor shows what the equation valued. I can also hit the green check in the text field to complete the equation and toggle between the expression and the calculated value using the equation button. I'll click OK and rebuild the part. Now I'll do the same to update the housing features dimension. I'll double click on the face of the feature. Double click on the 60 mm width dimension. Using the equal sign into modify box will allow me to radius dimension to the overall both global variable divided by 2. This time I'll hit enter to the keyboard to complete the equation and enter again will close the dialog. Rebuilding the part will update the geometry to the new value. Now I can control the overall geometry of the part using equations. I will open the equations dialog again from the feature manager tree. And by changing the value for overall boss and overall base, I'm successfully updating the feature of the model. I would like to add one more equation to this part. I need to ensure that the counterboard holes in the base plate maintain a minimum distance of 8 mm from the edges of the plate. The holes and the corner radius share the same and center point. I'll use this information to determine what size the fillet radius should be. I'll start by creating a global variable called minimum edge distance and set its value to 8. Besides just adding equation into the modify box for a dimension, equation can be defined in fields of the property manager or in the equations dialog. Since I am already working on the dialog, I will add the equation directly into the list of equations. I'll double click a face of the fillet feature I am interested to access its dimension. I want to create an equation that controls this radius. I'll click in the cell to add equation, then choose the radius dimension from the graphic area. The radius of this feature should equal to minimum edge distance, which I'll select from the global variable list, plus the radius of the counterbore. To make use of an existing dimension in an equation, I simply need to click it in the graphic area to populate in the text field, much like I just did with the fillet radius. To use a dimension from the counterboard hole, I first double click on a face of the feature to show the related dimensions on screen. Since there is only a diameter dimension defining this feature instead of a radius, I'll select that to use the equation and we divide it by 2. Once I hit enter, I click the green check to complete the equation. I can see the calculated value of the fillet radius and the geometry of the part has been updated. Making a change to the minimum edge distance, that's the required automatically update the radius value. If I ever need to delete a global variable or disable an equation, right click in a row of the dialog will give me these options.